Okay, so this is your Chapter 8 lecture, and this is about getting there quicker with geospatial technology. So, sometime between the early 1990s and today, uh, the act of navigating really began to evolve from looking at paper maps to using internet services to print off maps in specific turn-by-turn directions by the early 2000s to more complex navigation aids like TomToms and things like that, on to services like Google Maps being available on smartphones to where you could literally navigate by foot, by car, or by bus, or however, from one place to another. And all of this is based off of geospatial technologies. So this example here shows a network of roads, and there's one road here that is highlighted in blue. And if you're to go from one end of that to the other, that is the preferred route, according to this. Now, the interesting thing about these roads are, these are all topographically encoded excuse me, from the Census Bureau. And what that means is every road has a direction of travel. It has a starting point and an ending point, a starting number and an ending number. And as you travel along that road, going to an address on that road, the numbers are scattered out accordingly, so that if you want to go to 221 Willow Drive, if this blue line is Willow Drive, as you drive down it, at some point you're going to get to that 220, 221 distance marker. Now, it's not meters or feet or whatever. If the road starts at 0 and ends at 1,000, it divides the road up into units based on that numerical classification range. And from that, it can then say, okay, well, if from here all the way to the end is 1,000, then to here should be about 200, and here to there should be about 220. And then you get to 221 or 222, and this is where it gets interesting. One side of the road is odd numbers, and one side of the road is even numbers. And they call this process geocoding, and basically it's a way of physically representing addresses on a GIS map. And so here we have some examples. You can see all the zip codes and road information and all the different stuff, and where it starts from, where it goes to, what the values are. All kinds of information has to be in there in order for this to work. And so let's look at some of this stuff. This is commonly used road segment attributes and how they're named. And this is from the Tagger 2000, Tagger 2014 address range, feature, county, and national map transportation layers. And so you got these attributes like prefix direction of road, north, name of road, Smith, type of road, street, the suffix direction of road, canal, street, east, the start of the road address range on the left side of the road, start of the address range is on the left side of the end of the address range is on the left side, start on the right, end on the right, zip code on the left, zip code on the right, because sometimes roads make anti-boundaries and zip codes could change from one side to the other. And then there's other codes that tell you about the type of the road as well. So when you use something like MapQuest or TomTom or what have you, it lays out the roads and you put in an address and it literally finds that road, that zip, that street number, that side of the road to your location. Here's some breakdowns of what we're looking at. If you put in something like the White House, you know it's 1600 Pennsylvania Avenue Northwest. And so the number would be 16th Street, be Pennsylvania, type would be Avenue, suffix would be Northwest. You can break down these various addresses and use that to find locations in a GIS. And so this shows more about the individual address. and how the address segments on the right go from 301 to 399, and on the left go from 300 to 398. Odd on one side, even on the other. And that's for each segment of the road. So the road's not a single continuous feature, it's made up of multiple parts. This just is another example of how you can use this, another type of setup. This is OpenStreetMaps. And an example like this, you might go from point A to point B, and this is where GPS can kind of get kind of interesting. There's the shortest, and there's the quickest. There's the quickest given traffic. Lots of different options you have today. When these services first became common, they did not take into consideration much of that, and it literally asked you if you wanted the shortest route or the fastest route. And most people would pick the shortest route, assuming that they could actually drive faster than what the software might indicate, or that the shortest route would save them fuel or time or money. And where I'm from, there are a lot of roads that show up on old maps that just aren't very good roads to be used. And so what happens is a lot of these roads, they're not suitable for traffic, really. They shouldn't be on maps because not every vehicle can use them. And so what happens is, or what happens frequently at this one particular location, is truck drivers will get directions to go into this particular facility to drop something off or pick something up. And they'll plot the quickest path. And that'll take them on some pretty common standard roads that go. And then there's an opportunity to cut about 25 miles off the trip by taking this one little road across this tiny little mountain where you can't go with a truck. And if you drive across it, you will see on the rock outcroppings on one side of the road scratch marks up to about 10 feet high where a tractor and trailer have gotten stuck, and they've had to drag them around the turns with some parts of the wheels over the edge of the bank, while the rest of the truck, or the trailer rather, is grinding and sliding along the rocks, usually leading to a truck driver who is quite nervous when he finally makes it off of there. Now this is becoming less of a problem now, but in the early days of some of these GPS navigation systems, this was a pretty common occurrence. So as you set these things up, you can not only go from one spot to another spot, you can also set up multiple stops and look at what is the best combination of path to go to all these stops in the quickest time. And so it simply navigates all the possible combinations using distance or time and tries to find the path that takes you through all, in this case, 5 spots in the fastest time. Most navigation we do now probably is with our phones. The units like TomToms and such are pretty much a thing of the past. Built-in satellite navigation in automobiles, however, is pretty common still. But the drawbacks for many of these systems is the reliance on cellular connectivity. Oftentimes, the base map and road details about where you're traveling are pulled down in real time from the internet, and the GPS signals are from receivers built in the phones. And what will happen is you'll get outside of your coverage area. Maybe you've got an AT&T phone and you get outside of AT&T's range and you get into another provider's range, and you no longer have signal, and now your GPS, while it knows exactly where you are, you lose all your maps, and so then you can't navigate. This can be troubling as well. Maybe next week in class, if somebody asks me about it, I'll tell you a funny story about that. So here's a nice example of going to the street view at a particular address location in Google Maps. It's actually quite remarkable. You can look at it from above or at an angle, and it allows you to look around. This can be actually pretty useful if you're trying to figure out, if you're looking at like real estate ads, apartment rentals, that kind of stuff. You're trying to figure out what the neighborhood looks like. Simply put in the address, hit this little button there on the right that looks like a kind of a red and white arrow pointing both directions, and when you click on that, it goes from that 2D to that 3D isometric view that you see here, and allows you to rotate around and see the environment, and you can get a really good idea as a street level view what the neighborhood might look like. How do they do this? They collect a whole lot of georeferenced photos and then have really powerful computer servers that identify edges and boundaries and common features from one picture to the next, and they stitch them together in a 3D environment, so that when you access a location and you hit that button, it brings up the most recent pictures that they've taken there. Same way with the aerial photos and other data source layers. Every time they update their information, you get new and better information, but that doesn't mean that you're using necessarily the best available information. Everything happens on a schedule, so the new information about street addresses, street locations, street shapes, aerial photos, what have you, might exist, but until that information makes it through the work cycle at a place like Google Maps, the best you can do from them is the best that they have available for you, not necessarily the best that is available. And this has really made a lot of breakthroughs, particularly in terms of dispatching. Whether it's a 911 call for a fire, EMS, or police. You can also use it to look at possible exit routes and identify places for potential roadblocks, and there's all kinds of ways that this technology has really enhanced our ability to navigate in complex urban environments. And here's an example. We put in a location like Virginia Beach. You get a little snippet of weather. You can save the location so that you can go back to it later, or you can hit directions and find directions on how to find your way to Virginia Beach. And you can pick specific addresses as well and put in. Notice the Leave Now button. You can pick the time you want to depart, and it'll estimate the time you'll arrive, or you can pick the time you need to arrive, and it'll tell you when you need to depart. I literally will be using this tomorrow. Got to go to a meeting over at Pender. Actually, it's at Brault. So I've got to go to the Annandale campus, and I have no idea how to judge how long it takes to navigate Northern Virginia traffic at various times of the day. I just know sometimes it's much worse than others. And so I'll look at what time I'm supposed to arrive there, and then I'll punch that into this stuff and figure out, not because I don't know how to drive to the Annandale campus, that I can do without any problems, but I don't know how long it'll take me to get there. This is a godsend to help me figure that out. When you run these sort of tools, you get this road examples like this. You can, if you want, just simply click on a road and drag it over to another trail, another street, and it'll give you a different piece of information about how to potentially do that. But what really matters is when you see a line like that that's all blue, that means everything's moving good, or if it's green. When you see reds, that tends to mean traffic is not moving fast there. And when you see little symbols like you see there on the far right, about I don't know, maybe an inch or so in from the end, that could be something for road construction. These are things that are important, and some services update this stuff in real time, and it allows you to make real specific decisions about how to navigate where you're going so that you avoid as much congestion and traffic as possible. If you zoom in, this is an example. You can see the areas that are blue, the areas that are orange. Oranges are the slower, blues are the faster, and ultimately getting you to where you need to go.